Let's take a look at these scenarios real fast, and I'll let y'all pick which ones you wanted me to do with you. So in this first one, we've got the temperature change over time for a certain liquid. So we have the time passed in minutes and the temperature. And this was used to predict after 5 minutes, they predicted it would be 63 degrees Celsius. And we just have to answer whether or not that prediction's correct or not. In this one, we're given the number of absences versus test scores for some students. Same thing, given a prediction that was made, we want to answer whether that's a good prediction, a correct prediction or not. And then if you flip over, the other types of examples are you're given the data, okay, for two different groups. In this case, two advertising companies, okay, and their profits. So you are comparing two data sets. Okay, so it says if you spend 50,000 on advertising, which company would be the best one to go with? Okay, so 3 is comparing two data sets. 1 and 2, we're asking you to state whether a prediction was accurate or not. And then I believe number 4 is also comparing two data sets. So I'm thinking we should do 1 from the front, where you're answering whether it was a correct prediction or not, and then 1 of the comparison ones. Do y'all have any preference if we do 1 or 2? No? All right, let's just do number 1 then. All right, so I'm going to pull up Desmos and enter my data. Over here. Desmos. So remember, the process in our calculator is add table and then enter our X and Y values. Okay, and we have to make sure we can identify which is X and which is Y in our table. Okay, if you need to label that, make sure you're labeling. So over here in the time versus the temperature. The temperature is dependent on how much time has passed. So the temperature is the dependent X and the time is independent. Or I said that backward. The temperature is dependent Y and the time is independent X. Okay, so we've got our X and Y, so I'm going to put that in our table. Scroll so I can see all those values. All right, so in my X column, I've got 1, 3, 6, and 8. And here I've got 78, 69, 55, and 50. Okay, so then remember, after you've got your data entered in the table, you go to the next blank line in Desmos, and you're typing Y1 tilde MX1, oops, plus B. Okay, and then all that data is going to populate for you. Okay, so I'm going to take a little screen grab of that to put on our notes. This full screen again. All right. So here's what we got from our table over there, or from the calculator when we entered our data. So now they say this data was used to predict the temperature after 5 minutes and it's the 63 degrees Celsius. Is this prediction correct or not? So we're going to go through and we're going to check. We're going to write the equation of the line of best fit and use it to make the prediction and see if what they predicted is accurate. Okay, now take a look at your R squared value. We talked about the R squared value yesterday. We said that R squared is your coefficient of determination. And what do we want for a good fit for our equation of the line of best fit to be a good fit for the data? What should that R squared be close to? To 1. It's going to be between 0 and 1, and the closer it is to 1, the better the fit. 0.9885, that's pretty close to 1. So I think this equation that we're going to write is going to be pretty accurate at making the prediction. Okay, so remember we are plugging in M and B. Okay, so down here we've got our M. We're going to put here. And we've got our B. We're going to put here. And then we will plug in. They're asking us to estimate the temperature after 5 minutes. So they're wanting us to plug in a 5 for X. Okay, so I'm going to write the equation first, would be negative 4 point, did they tell us? They did not say what to round to. So the further your decimals go, the more accurate. So let's just go to thousandths like we did in yesterday's notes. So we'll say 103. And then our B would be 81.466. Okay, and they want us to plug in 5 for X. Okay, so you can individually plug in X values and make predictions here like this. So I'm going to pull my Desmos back up and I'm going to come over here and I can type in that equation, negative 4.103 times 5 plus 81.466. So that prediction that we get here is 60.9, which they predicted 63 degrees. Let's check. What if I used all of these decimals? Let's see if that gets us a little closer. So I'm going to say 4.10345. And I'm going to say 81.4655. Still at 60 point something. Okay. So it didn't matter how close, how many further decimals we used, it still didn't get us to 63 degrees. Okay, so I'm just going to leave it back at the hundredths then, but it wasn't a bad idea just to double check that. Okay, so I'm going to say our estimate is 60.951. Okay, so was this an accurate prediction? And I'm going to say no. Whoa. Well, I'm going to open that back up first, and then I'm going to say no. Because after 5 minutes, temperature is approximately 61 degrees. Because I'm rounding that, all of those values are to the integer. So I'm going to round 60.951 to 61 degrees Celsius. I do want to show you one more thing in Desmos. Okay, I think in one of my class periods, somebody asked about it, so we talked about it, but I don't know if we did in here. If you end up with a question that you're using the same regression model, remember this is our regression model, the equation that we came up with. If you're asked to make multiple predictions from the same model, instead of typing it in here with the X value input, sometimes maybe it's easier for you to write it as an equation with X, okay? And we can get rid of all the rest of this, okay? But write your equation like this, y equals mx plus b, and then make a table from that. Because then you can just type in whatever you want the prediction of. When x is 5, boom, 60.951. If they asked you predict at 10 minutes, boom, you've got your prediction. Okay, so sometimes it may be easier to type the equation as y equals mx plus b and make a table for that data, and then you can type in whatever X value they're asking you to predict for. Okay, now if you're only making one prediction, I don't know if that's much faster than the way we did it before, but it's another option, okay, a way that you can make those predictions. So far, so good? All right, we're going to skip number 2 because number 2 would be done the same way. I'll do this in another class and end up posting all of this completed if you would like to try it on your own. And then you can go back and check it where I post the completed notes.
The reason.
What's the reason what?
That
Well, our reason is our work shows that our equation, when we calculated it, we got 61 degrees. So their prediction of 63 degrees was incorrect. Because when you input 5 minutes into the regression model, you get 61 degrees. All right, so 3 and 4 are both comparing 2 sets of data to find the best option. Do y'all want to do 3 or 4, or do y'all have a preference? All right, we'll just take a look at 3, and then I'll do 4 with another class, and I'll end up posting this all. Okay, so you can try 4 on your own later and check it, or at least go copy it down if you just want to see it done. All right, it says you have a budget of $50,000 to allocate for outreach efforts for your charity. 2 organizations, Organization A and Organization B, have provided you with data on the potential impact for donations based on the amount allocated. So we have Organization A, okay, so this is their annual advertising in thousands, okay, and this is the annual profit in thousands, okay, so what you're going to be inputting is 50,000 for advertising. So that's going to go in this column. They're going to say, if we put a 50 in here, what's our predicted profit? Okay, so we need to come up, same thing here with Organization B. So we need to come up with the line of best fit, a regression model, an equation for both of these, and plug in the 50 and see which one gives us the higher annual profit output. Okay, so that's what we're going to do. Okay, so we are going to go back to Desmos. So I'm going to clear everything out. Okay, and I'm going to do one at a time because I don't want to get my data mixed up or messed up when I'm writing my equations. So I'm going to look at Organization A first here on the top. So we've got 8. Oop, that's not where I meant to be typing 18. Here's where I meant to be typing 18. 16, 23, and 27 and 35. And the profits were 62, 60, 130, 116, and 148. I'm going to do y1 tilde mx1 plus b. Okay, so I'm going to write my equation over here based on this data. Okay, so I'm going to grab that picture again. Stick it in here real fast. All right, so this is Organization A. Okay, now we're going to do the same thing for Organization B. Hey, the notes outline is back here on top of those trays if you want to grab one. All right, so I'm going to just clear it out. Add a table. All right, so for Organization B, I've got 12, 18, 26, 32, and 41. And then for my Y's, I've got 44, 55, 119, 120, and 219. So again, my y1 tilde mx1 plus b gives me my data. Let me copy that real fast. Come back over here and put that info in. All right. So now I'm going to write my equations. Okay, so for organization A, this is my M and B. Okay, so for organization A, I'm going to have 4.75 4. I'm going to go to thousandths again. Minus 9 point, and then that would be 943. So that's my equation for organization A. Now organization B, scroll down here a little bit. That's my M and B that I'm going to write the equation for. That would be 5.876 minus 40.210. Okay, so now I'm going to use both of these equations, okay, and I'm going to input 50, not 50,000, because notice it's already in thousands. Everything's in thousands already. So I'm just going to input a 50 for my X, okay? So I'm going to input the 50 for both of these to compare. All right, so for organization A, it's 4.754 times 50 minus 9.943. And for organization B, it's 5.876 times 50 minus 40.21. Okay, so when I compare these, I'm going to put the information down here that I got plugging into this. So on top was organization A, and on bottom was organization B. So which one gave us the higher output? Which one of those numbers is larger? This one is higher. This was organization A, this is organization B. Okay, so, and then it asks, so organization B is our answer to this first question. And then it asks how much, I think that's supposed to be greater. How much greater will the profit be compared to the other company? So what am I supposed to do with those two numbers to answer this question? Yeah, I'm going to subtract them. So I'm going to take the higher profit. Now, if you want to go ahead and convert this, it said in thousands. So this is 253,590. We'll go ahead and convert that. And this is 227,757. And we'll go ahead and do that subtraction. So 253,590 minus 227,757. So that comes out to a difference of 25,833. And this is dollars. Notice you can make a note here. I put it in thousands. Put it in thousands of dollars. All right, So this is how you do comparisons. So you have to come up with your equation for both. Sometimes you'll be given the equation for both and you just have to do this plugging in and checking and comparing and then calculating the difference if they ask for the difference. So going with company B should make me about $25,000 more than if I had gone with company A. Y'all feel okay about that? All right, so y'all have the rest of class to go and practice. You have 2 regression assignments in Delta Math. You've got one of them just says linear regression. That was from Wednesday. And one of them says linear regression day 2. That was from yesterday. Okay, so you need to go work on getting both of those completed. And if you get them done, you don't have any homework this weekend. Enjoy your 3-day weekend.